Okay, we're recording. All right, so what I'm going to do is we're going to scan our volumes and we're going to scan our masses. And I think we came up with the biggest mass was what, 120? I think somebody got that? About 120 is the biggest mass?
Yes.
Okay, so you know what? That means that I just have to have 12 spaces up the side, 10 grams up. Okay, or I can go by fives. All right, so I take my mass. So the first mark, mass versus volume. Okay, so guess what? In a test situation, I just earned a mark. If you didn't have a title, I took off the mark. Okay, and because we know that, did I forget to give you a graph paper? Okay, it's not a bad idea for you to do this so that you have it. Okay? Now, we also know that when you have zero of something, zero mass, zero volume, we know that zero is where we're going to land here. Okay? And I'm going to go up the side, so I'm going to put mass, and I'm going to put grams. Okay, that's another mark. And on this axis, I'm going to go volume and cubic centimeters. Okay, another mark. And along the mass, I'm going to go by, I think I'm going to go by fives. So 5, 10, 15, 20, 5, 30, 35, 40, 45, 50, okay, so that uses the whole graph that way. And in volume, my biggest volume is 15 cubic centimeters, so I'm going to count by ones along here. 1, 2, 3. And that's just inspection of the table that I provided. Okay? If you did it any other way to spread it out, that's fine. But you notice this is going to use the whole graph paper. Okay? And that helps us when we do our line of best fit. It also helps us when we put on our points. So, that's the layout. That's 1, 2, 3, 4, 5 marks. And guess what? I'm also going to put my name on it. So my name's on it, not on it, I don't get marks for it. Pardon me? Thank you. And because when you are looking at scientific data, anything you start to produce, if you're trying to prove your stuff, becomes a legal document. Okay? So I'm going to move down here. So I have name, date, title. Okay? So I'm only going to pay attention to material A. Now, as I said, sometimes we have problems with our eyesight. So what I'm going to do is I'm going to actually fold the paper. Did I tell you you can't fold your paper? Okay. So I fold the paper so I'm only looking at the table that I want to worry about. Okay. You can make your job easy by doing these things. All right? Oh, by the way, somebody said to me, can I just calculate the density and figure out those answers from here? Yeah, you probably could. But that's not the process I wanted you to work from. No, it's true. I wanted you to do it this way. Okay, so I look at my first one. My volume is 0.6. which is just a little bit above, and my mass is 4.4 grams, so that's 2.5. So 4.4 would be approximately there at 0.6. So there's my first mark. And then my volume 1.7, so 1.75 is there, so it'll just be inside of that, and 12.4, which is almost 12.5 exactly. So for my graphing purposes, that's where I'm going to put 1.7, and I'm going to go a little bit there. Okay, 1.7. And look, I'm already confused, so I'm going to put a little check mark that I've done those two. Okay, because that's what you need to do. It's a process, all right? The next one is 2.3, so that'll be a little bit less than 2.5, and my mass is 16.8, so that's 17.5, so 16.8 is going to be about there. Put a little check mark. And the next one is 3.9, which is just a little less than 4. And my mass is, a little less than 4, and my mass is 28.5 grams, so that's 27.5 grams, so it'll go up just a little bit from there. 28.5 is almost 29, so it'll be approximately there. And I put a check mark, and the next one's at 6, which is kind of nice. It's right on an axis. And 43.9, I go up to 42.5. 43 will be there, so it's just a little bit less. It's just a little bit less about there. So that's on that axis. I put a check mark. Ooh, this one's back at the 5 axis for volume. So I go back to the 5 axis for volume, and I go 36. Well, that's 35. I know that's 37.5 based on my axis. So I go approximately there is 36.6 grams. Put a little check mark. The last one is 109.7 at 15 grams, 15 cubic centimeters. So 109, oh, you know what, that's kind of going to land in here. So you know what, I'm not even going to put that one on because there's no graph right now. So I'm just going to knock that off because I have 10 points. I can choose to leave one out, okay? It's not wrong to leave one out if it doesn't land where you can plot it. Okay, so the next one's at 11 and 80.4. So there's 80.4 is just going to be a little bit above that. And I put a little mark, and I put my check mark, yes. And the next volume is at 8 and 58.5. So there's, well, I know that's 57.5, so 58.5 is going to be approximately there. And the last one's at 7. I come back to 7, and it's 51. So there's 50, and there's 1.2. It's about there. Okay, so now I find my ruler to find my line of best fit. And if I've actually done this right, my line of best fit should hit pretty nearly all my points. Okay? And I'm not far off. And I'm going to choose to make this line very dark. And because we knew we have a data point up here, I can go all the way up to there, and I can even include the one that I didn't include. And before I go any farther, I put an A on that line so that I know that's material A. No, seriously, because some people did a nice graph and they didn't label what their line was, and when they came back to calculate their slope, they didn't know what they were doing. They didn't know who they were talking to. It's like me calling you Bella. You're not Bella. No. I mean, it's just that you had the wrong name on the line. Okay, so now the next thing. How do we calculate a slope? Well, I'm looking at this. You can't quite see it as well as I can see it, but I can find something that crosses, my line crosses both axes. I like this place right here. So I'm going to put an X there because that crosses the axis in both places. Okay? And then I'm going to find one a little bit lower. Oh, look, it crosses the axis right there. Okay. So what I've done is I've shown specifically, it doesn't have to be one of my points, it has to be where my line goes through. I get to choose those. Okay? I am the maker. That's my choice. So, the next thing I'm going to do is I'm just going to lightly draw a line because I might want to erase it. I don't know yet. So I lightly draw a line, and I lightly draw a line up the axis this way. I can always go back and put these in because I need them for my marks. But I don't know where my space is going to be yet and how it's going to work out. But I do this first for material A. Okay? Now, what I've done is I've set up for going from left to right. I'm going to call that 0. And because a whole, or 2 squares, is 1 cubic centimeter, I'm going to count 1, 2, 3, 4, 5, and this is going to be 5.5, right? 5.5. 5.5, and that's cubic centimeters. Okay, ladies and gentlemen, it's important that you know what the unit is that you're working with. You have to include that in what you're doing. So that is going to be the run. So I'm going to put my little arrow up here, and I'm going to write 5.5 cubic centimeters. So far, so good? Now, I will put 0 here, and I'm going to count up. Every 2 squares is 5 grams. So I'm going to go 5, 10, 15, 20, 25, 30, 35, 40. So I'm just going to write that in now. 5, 10, 15, 20, 25, 30, 35, 40. Okay? And that means that my rise is 40.0 grams. And what number did you get? 7.27. Okay, I like that number. Okay, so for material A, I have 7.27 grams per cubic centimeter. I go to my test paper, and in this case, I'm going to write the density of material A is 7.27. And that's grams per cubic centimeter. And then I look along here and I find, oh, that's dangerously close to the density given for tin, so that's tin. Okay? So that's the first one done. By the way, how long did that take me? It took me 10 minutes. It's going to take me less time to do the next one and the next one. By the way, if I'm not talking, I can do this much faster. Okay? So the thing is that I know I gave you enough time to do that, because once you've done the setup, you plot the next one and do it. And then plot the next one and do it. Do you need me to do one more?
I thought that was amazing that you did it because of your 2 points.
Yeah.
My 2 points were like this.
Okay, that's a good point, Mel, because you can choose. Here, let me just show you. I could choose 2 points. I could choose this point here and that point, and I could do the calculation from there. Okay, so if I did that, well, that's 7.5 grams per, it works out to 7.5 grams per 1 cubic centimeter, which is almost the exact density of tin. But here's the thing. If I use a slightly larger one, you'll notice that my calculation comes closer to what the density is. So you don't want to make it too small.
No.
Okay.
I just thought it was, like, I never put the two and two together, I just figured.
Yeah. But if, look, I could use this one here, and I could go all the way down to 10, okay, and what's that at? That's at 70, look, that's at 72.5 divided by 10, 7.5. Close enough to answer the question, right? So the thing is that wherever you choose, it will work, okay? And it's close enough to show me that you know how to do it. Okay, let's look at one more. Shall I do one more? Okay, shall I do one more?
Yes.
Thank you.
Yes.
Okay. All right, so now let's look at material B. So you'll notice that because my old eyes don't work so well, I fold the paper, so I'm only paying attention to what? Material B. Okay, there's no rule that says you can't fold the paper to make it convenient for yourself. As long as you don't rip the paper, you can fold it. Right? No rule that says you can't. Okay, so what I'm going to do, let me see, can you see red okay if I work in red? Can you see? Yes. No, green maybe. Let me see if green will work.
Better.
Green's a little bit better? Okay, so, again, I find my volume, and I tend to choose the one that's left, right. I tend to choose the x-axis, and I slide back to 0.9, which is a tenth of the space, and I go to 9.5 grams, which is approximately there. Okay, and then I go to 1.2, which is there, and I find 12.6. Well, we know that this crosses at 12.5, so 12.6 will be about there. And then I go to 2. Oh, lost it. I need to check these off. Check, check. Part of the process is checking as you go. Okay, so now I go to 21. All right, so 2 and 21, so that will be 22 and a half. So 21 will be a fifth of that space, which is approximately there. And the next one's at 3.5. 3.5 along the bottom, and 36.8, which will be a little bit less than 37.5, which will be there. And the next one is at 4.2. Okay, and 44.1. Okay, so 44 is about there. 44.1 will be about there as well. Oops, I missed the dot there. That's the one I want. Okay, and you know what? I don't like that 4.35. It's too close, so I'm going to go to 5 because I like it better. And you know what? Again, I can choose what I plot and what I don't plot. 52.5. Oh, that's perfect. That's bang on, right? So 52.5. And you know what? I'm happy with everything I've plotted. I'm going to put a line of best fit. All right? Nope, I got to check this one. That's 4.2 and 44. Oh, heck. 4.2 and 44, I put it one up one. And when you come to do your line of best fit, it allows you to figure out whether you put it in the right place. I didn't put that one in the right place. I went back and fixed it. Is it okay to do that?
Yes.
Yeah, absolutely. So, again, the same logic. 0 of something has 0 mass and 0 volume, so I can legitimately include 0. I draw a line, and I label it immediately B. Okay? Why did I label it right away?
So you don't forget.
Yeah, because you know what? I'm under pressure here. I'm writing a test, and I want to get 26 out of 26. Okay? No, but you see how the details work? Okay? Pardon me?
One at a time.
Absolutely, one at a time, one line at a time. Okay, so I'm going to calculate the slope of this one, and I like where it hits the line here, and I like where it hits the line, I don't know. Oh, I like where it hits here. All right. So now I can kind of ignore the other one. I'm working in green pen. All right. And I draw in my run. And I draw in my rise. And I'm going to do that on this side. I'm going to count. Remember, we are going by fives here for every 2 squares. So 5, 10, 15, 20, 25. So 25, because this is 0. So my rise goes to here. 25 grams. Okay. And then I go here per, let me see, 1, 2, okay, so I can put my 0 here. I go 1, 2, so this is 2.5. 2.5 cubic centimeters. Okay, so 25 divided by 2.5 equals 10.0 grams per cubic centimeter. By the way, even with all the talking, that took me less than 10 minutes. That took me 5 minutes to do it. Okay? Because I did it step by step. I followed the process. Okay, you have to follow the process. So now let me go back to my test paper. For material B, okay, for material B, I put in a density of 10 grams per cubic centimeter. I check along the bottom, and I find the one that's closest is silver, so my density is 10, and the material that I identify is silver. Okay? This is starting to make more sense? But ladies and gentlemen, I'm just going to turn this off now.